When trying to estimate some sample proportion, we need to know how big our sample needs to be. So how do we find it? Well, there are two formulas that we can use. One we use depends on whether we know p hat or not. So if we know what p hat is, if it is known, then we use this formula here. Z sub alpha over 2 squared times p hat times q hat over the margin of error squared. If we know nothing about p hat, know nothing about the proportion, then we use z sub alpha over 2 squared times 0.25 over the margin of error squared. You can see that the two formulas are pretty similar in all aspects except for if p hat is known, we do p hat times q hat, and if the proportion p hat is not known, we use 0.25 instead. If the sample size n is not a whole number, you need to round it to the nearest whole number. No exceptions. Even if that decimal is 0.0001, you always have to round up to the next one if it is not a whole number for n. So let's look at an example. Jennifer Bates has just been hired as a manager of a company that provides cell phone service to people. She wants to determine the percentage of adults in your state who live in a household with cell phones and no landlines. How many adults would she need to survey if she wants to be 90% confident and be within 4 percentage points? So from here, we know that our confidence is going to be 90%, and we want to be within 4 percentage points. That means that's our margin of error, because we want to be within 4 percentage points of being correct. So, in part A, assume that a recent survey suggests that 8% of adults live in a household with cell phones and no landline phones. So, we have a percentage. We have a p hat value here of 8%. So, p hat equals 0.08, which means q hat, which is 1 minus p hat, is going to be 0.92. So 1 minus 0.08 is 0.92. We know from the original question at the beginning that our margin of error is within 4 percentage points, so E is going to be 0.04. And we still have to find our Z alpha over 2 because both formulas require that. So our alpha over 2 is going to be 1 minus 0.90 over 2, which is just going to give us 0.05. So Z of 0.05, we got to find that critical value, and you can do it two ways, calculator or table. I'm going to show both. So let's look at the table, and we're going to look for the closest to 0.05. And 0.05 is actually right in the middle between these two values here. So 1.6, and up here, since it's right in the middle, 0.045. So our z-score here is going to be 1.645. So going back here, 1.645. And now we're going to find the sample size, what we need. So since we have a proportion that we know, the p-value, we're going to be using this formula here. So we're going to have n equals, put in brackets here, 1.645 squared times p hat, so 0.08 times 0.92 all over 0.04 squared. And now we just run this through, and we're going to end up getting a decimal. So I'm going to bring up the calculator so we can see it in action. It'll block a little bit of it, but that's okay. So we're going to have 1.645 squared times 0.08 times 0.92, and then divide by 0.04 squared. And that's going to give us 124.47. So we need to actually round that. So I'm going to say that this is 125. So how many people do we need to get in our survey? 125. Now, you can also use your calculator to find the critical value as well. If we were to do that, we already did all the work, 0.05. You would just go to second vars inverse norm and do 0.05 as our area. And here we get 1.6448, which does round to 1.645. But many times when we do the critical value, we only round to 2 decimal places. So what if you actually rounded to 1.64 instead? Well, the answer is just going to be slightly different. So n equals 1.64 squared times 0.08 times 0.92 over 0.04 squared. How much of a difference? Like I said, it will be different, but it'll just be a small difference. So 1.64 squared times 0.08 times 0.92 divided by 0.04 squared. And we get 123.7, which rounds up to 124. So technically both answers are correct, but if you use a table, you would get 1.645. If you use the calculator, you get 1.64. But again, both answers are correct. Just it depends on what critical value you use and how you round. Most of the time, the critical value is just 2 decimals, but this is an odd one where it can be 3 decimal places. So again, both are correct. Just be careful of your rounding and be clear of what number you do use. Now, what if we know nothing about the percentage of adults who live in households with cell phones or landlines? Well, we already know what our z alpha over 2 score is, 0.05, which is either 1.64 or 1.645, depending on use a table or a calculator. And we know that our margin of error is still 0.04. So here, n is going to equal, and I'll do both just to show, 1.645 squared times 0.25 over 0.04, and n equals 1.64 squared. Oh, there's a square here. Almost forgot it. 0.25 over 0.04 squared. So what's going to happen here? Well, again, there will be slight differences, but not really big, but just enough that you need to be mindful of it. So 1.645 squared times 0.25 divided by 0.04 squared. And so we get 422.8, which will round up to 423. 423. And then we're going to do it again for this other one. 1.64 squared times 0.25 divided by 0.04 squared. And we get 420.25, which rounds up to 421. So again, whether you use the table or you use the calculator, the answers will be the same, but I wanted to show an example of where 90% confidence will give you, if depending on the critical value used, could be just a little bit different. Again, just make sure you're clear at what your critical value is if you use a table, which I rounded to 3, or if you use a calculator and you round to 2.